Now let's discuss question number 49. It states that in an AP arithmetic progression of n terms, if the last term is negative of the first term, then the sum of n terms of AP is. So what will be sum of n terms? You are aware with the formula of sum of n terms of an AP, that is n upon 2 into a plus l, where a is the first term and l is the last term, n represents number of terms. Here it is being stated that the last term is negative of the first term. So I have here the last term as negative of the first term. So this last term will be minus of a. You can observe this gets cancelled. And I have here 0 into n by 2, the sum of n terms as 0. That means sum of n terms of AP is 0. That is clearly option number 4. The correct answer for this question is option 4. I hope it is clear to you. Let's proceed to our next question. Now let's discuss question number 50. It states here that if a and b are the roots of a quadratic equation such that a square b plus ab square is equal to 84. Also a and b are natural numbers, then the equation can be out of these 4 options. So what could be the possible quadratic equation? Here we have the condition that a and b are the roots of quadratic equation. Moreover, a and b are natural numbers. And here we have this condition that a square b plus ab square is equal to 84. When you simplify this equation, you obtain that here we have ab common for these both. That gives me ab into a plus b equal to 84. Now this tells me that I have product of the roots taken product with the sum of the roots. This gives me 84. So what could be the possibility for the numbers which are natural numbers to give the sum and the product whose product is equal to 84. So this could be 1 into 84, or this could be here 7 into 12, or this could be here 4 into 21 and many other possible numbers. But I need 2 natural numbers whose sum and the product could be out of these. So what could be the possible number here? So when I consider 12, 12 is considered to be 3 into 4, and 3 plus 4 gives me 7. So this is one of the possibility which is clearly found here in option number 3. But when you take here 4 and 21, you don't get such a natural number whose product and the sum will be 21 or 4. So that's why here I get the correct answer as option number 3. This is the required quadratic equation according to the given condition. I hope it is clear to you. Let's proceed ahead to our next question. Now let's discuss question number 51. It states that in the sequence a plus 3, b plus 6, so until z plus 78, the difference between any 2 consecutive terms is minimum, such that every 2 consecutive numbers out of a, b, c, d, so until z are co-prime numbers, and a is equal to 1. The sum of all terms of the given sequence equals. So here you have to find the sum of all the terms of this sequence, that is a plus 3, b plus 6, so on till z plus 78. As here it is given that a is equal to 1. So if I consider a as 1, here the first term will be 1 plus 3, that is 4. As I have to keep here the difference of the 2 consecutive terms as minimum. So I can consider here 2 plus 6. That will be 8 as the second term, where I am taking up the difference as the minimum. Moreover, I have to take care that every 2 consecutive numbers out of a, b, c, d, so on till z are co-prime numbers. So I can take these 26 alphabets as the 26 numbers, because 2 consecutive numbers have the minimum common factor of 1. So here next term will be definitely 3 plus 9, and so on this will continue till the last number, which is 26 plus 78. So this is our sequence. In this case, when you simplify this, you get this as 4, 8, so on till 104. These are 26 terms which is clearly in AP having the first term a and common difference of 4. So let's take here sum of this AP 26 upon 2 into first term plus last term, which is 4 plus 104. When you will solve this and simplify this, you will find your answer is 1404. So the correct answer for the sum of all the terms of given sequence is option number 2, that is 1404. I hope it is clear to you. Let's proceed ahead to our next question.